My name is Dominick, and as always, I have way too much content for 60 minutes, so let's get started. Thanks for your time. And, as you probably, well, if you know me, you know that I spend most of my time, with OAuth and OpenID Connect and token-based security systems and so on. So what this talk is all about is basically the things that, if you are having OAuth up and running, the things that might be worthwhile looking at in 2021 to improve your system or make it more secure or be ready for certain regulations or standards, or just to be aware of that these things exist in case you need them at some point. Cool. So the only really important thing here is you have my email address on this page here. Also, you have I uploaded the slides already to speakerdeck.com/leastprivilege. I also put the link into the Slack channel. So from there you can get the slides, and that has all kinds of extra links and extra reading on it, and also my email address and my Twitter handle and so on. And that's how you can get a hold of me. Cool. So this is primarily a protocol-centric talk, but I'm going to show you some demos. And as you probably know, I've been working on this OAuth framework for ASP.NET Core for quite a while. It's called IdentityServer. We recently moved the repos to a new repo, which is under my new company called DoEndeSoftware with a new license. So we changed the license so that commercial projects now need a different license, but we still have a free version for open source work and smaller companies and so on. So you can just use this. You don't even need a license at all to try the samples and the demos and so on. So just that you know that all of the new work and so some of the newer features actually that I'm going to show are now available in the new version. You can find all the source code and all the demos in this repo basically and organization. Okay, cool. So what's on the menu, so to speak? First of all, I want to talk about OAuth 2.1, which is a protocol revision, which is probably going to be released this year. And then, which, makes things a little bit, makes things considerably more secure, more well-defined. Think of it as an updated version of the original spec. And then we're going to look at some topics that I think are really important, which are not very widely used, but they should be used, I think, because they are available as technologies and they improve the security of your systems. Yeah. And one of them is definitely something around key rotation and upgrading to more modern signing algorithms. We're going to talk about this new JSON Web Token profile for OAuth access tokens, because funnily enough, even if people are using shots for quite a while now in OAuth, there has never been any sort of standard or anything around it. But that exists now as well. So we're going to have a look at that. We're going to look at something called resource isolation, or in more detail, a spec called resource indicators that allows you to isolate, resources from each other, which is an interesting thing as soon as your API surface has a certain size. We're going to look at char and par, which is basically, which are two standards that help securing the front channel in the browser and making that more secure. And then finally, at the end, we're going to look at a topic that many people have been asking about and looking for, is how to bind access tokens to the client so that if in case they are leaking on the wire or in log files or wherever, someone that finds these tokens or an attacker cannot simply replay them. And that is called proof of possession. So let's have a look at those things. Okay, cool. If there are any questions, I will look at the Slack channel afterwards, and we can also do afterwards voice if you want to. As I said, I have a lot of material, so I probably don't have the time to answer questions in between, but ping me afterwards. I'll be around and answer any question you have. Okay, let's get started. So OAuth 2.1. As I said, 2.1 is a revision of the OAuth 2.0 spec. Funnily enough, I think what they're doing is exactly reverse semantic versioning. So, in normal semantic versioning, you would just add stuff and don't change existing stuff or even remove things from a library, and they're doing exactly the opposite. They are not introducing any new features, but they are removing existing ones. So let's have a look what they are actually removing. The next thing they do with OAuth 2.1 is basically consolidating a whole number of different documents that have been in the works for quite a while called BCPs, or best current practices. So there's one for native apps and one for browser-based apps and one for JSON Web Tokens and so on. And they're basically consolidating all of that guidance in these documents along with the updated protocol restrictions into a new cohesive document, which they call OAuth 2.1. So probably the biggest change that many people know about is that the so-called implicit flow is now deprecated in OAuth. The implicit flow was added in 2012, now 9 years ago, to overcome limitations of browsers around doing cross-origin communication with AJAX. So they found, or were looking for a hack, if you like, how to transmit tokens across site boundaries. And they came up with the URL, which was by the time the only solution. And everybody knew that this is not really ideal from a security point of view, and that there are many caveats apply here, and you have to think about many things to make this better. But by the time, this was the only way to make, sparse work, and that was a high priority. So they came up with this thing called implicit flow. So just to quickly show you how that works, basically the JavaScript client makes a call to the authorization server, and then instead of the usual back-channel communication that is typically done with, server-side application, for example, the authorization server sends back the token directly in the hash fragment of the URL. And that has many downsides. Things leak in log files and in browser history, and there are injection attacks around that. So long story short, fast forwarding to 2021, this is not needed anymore because we have solved the cross-origin AJAX problem with CORS, and that's a couple of years ago. And we have solved, to be honest, the original problems that led to the implicit flow, which was the limitations around cookies, which are now also updated with the same-site cookie security sandbox, if you like. So in long story short, the implicit flow is not necessary anymore. You are not having a massive security problem if you implemented it already correctly, but it's hard to get it right. So if you have an existing application using it, have a look at if you might want to change that. And if you're writing a new one, definitely don't use it anymore. Okay, next thing. The next flow that has been removed or deprecated is the so-called password flow, right? And the whole idea of instead of collecting the user credentials on the authorization server, instead in the client application, was an anti-pattern to start with, and the spec pointed this out, but said there might be some legacy reasons you want to do that. In OAuth 2.1, the password grant is gone. Okay, so from a spec point of view, this does not exist anymore. It is an anti-pattern, if you like. Users are being educated to type in their passwords in several places and several times, which you want to avoid. This thing is not compatible with modern authentication flows like FIDO and Federation and so on. So it has been removed. I know that many of you out there are using it, and the main reason they're doing it is for legacy scenarios where you have existing applications that you simply can't change to use the browser-based flow. There's no OAuth police coming to your door and arresting you if you're doing it still, but it's gone from the spec, and maybe for good. So the nice thing about this simplification is when you look at all the different flows that we used to deal with for the different types of applications, some of them are gone. Implicit and password is gone. Some of them have been upgraded. The code flow, for example, has been upgraded to provide the same security properties as the hybrid flow in OpenID Connect, which the nice thing is now, if you look at that, you can really simplify it basically to saying like, if it's a machine-to-machine style communication, use the OAuth client credential flow. If it's an interactive application, use the code flow with this extra thing called PXE, which I'm going to explain in a second. And that applies to both OAuth, like pure OAuth scenarios, as well as OpenID Connect and OAuth or OpenID Connect only scenarios as well. So this works for all of them, which is good because it simplifies things, and it, you can focus on these two things. Make sure you understand these two flows, which is much easier than trying to understand 7+ combinations. Yeah, good. What's this PXE thing I just mentioned? So PXE is an additional specification, an RFC, that solves the authorization code injection attack. And basically the idea is that it adds an additional secret in the mix, which is not statically configured, but is dynamically generated. And the authorization code injection attack, the problem here is that in theory, the whole idea behind the code flow is that if an attacker would steal the code, it cannot redeem the code because it's missing the client secret. But this is not always true because some applications don't have client secrets, right? Like native apps, for example. And still, what the attacker still can do is take the stolen code and inject it into the legitimate application and make the application redeem the authorization code. Yeah. So to mitigate this problem, PXE was created, and that's not new actually, which basically says, okay, you add an additional secret, as I said, to the mix, which is called the code challenge, which is a hash of a secret. And then on the back channel, basically you send the clear text secret. And then what the server can do is compare the hashed secret with the hash of your clear text secret. And if they match, you have proven that you are the same client on the front and the back channel. Yeah, and that prevents basically injection attacks where you would use a different client instance for the front and the back channel. And that is very effective and very easy to implement because all you need to do is add this random number hash to your front channel and problem solved. Okay, so one of the things that OAuth 2.1 introduces is that you must use PXE if you're using the authorization code flow to prevent this problem. And the good news is, like ASP.NET Core, for example, since version 3 actually has that built in. So there's really nothing you need to do for these scenarios, which is good. Okay, and the last thing I want to point out is that the next thing that the OAuth 2.1 spec explicitly hardens, if you like, is how you should validate your redirect URI. So, and the original spec didn't say anything about that, and there are different ways how you could implement this. Some people use wildcards, some people use regular expressions to provide certain patterns, and all of them have been proven wrong over the past years with various attacks that specifically targeted weaknesses in your URI validation, right? And that is both on the the DNS name side as on the URL path side. Facebook, GitHub, you name them, have been hacked with these problems here. So the spec is very clear now. You need to validate URLs as an exact string match. No more wildcards, nothing else. The strings must exactly match from what the client sends you with the thing you have on hold in your configuration. Yeah, which is a small change but very important. So long story short, what OAuth 2.1 really is, it's RFC 6749, it's RFC 6750, which is the bearer token usage, plus all of these BCPs I mentioned earlier. And that together becomes OAuth 2.1. And just to summarize the changes, no more implicit flow, no more password flow. PXE must be used for authorization code flow. Redirect URIs must be compared using exact matching. Refresh tokens must be either sender constrained with a client secret or rotated on every usage. And tokens must not be sent anymore in query strings. Okay, so that's basically the 6 important things they did in OAuth 2.1. So that's the link to the spec. It's not done yet, but we expect this to land this year. Okay, let's move on. So the next thing I want to talk about is a feature in OAuth and in OpenID Connect, which is rarely used. Yeah, so when I look at all of the code reviews I'm doing or the companies I work with, almost no one, well, or a small percentage uses this feature. And what I actually mean is, when we look at, well, first of all, many OAuth systems out there are still using hard-coded configuration, yeah, like URLs and key material and so on. OpenID Connect introduced metadata, or what they call the discovery endpoint, and this was backported to OAuth as well. So there's an OAuth metadata or discovery specification, and the one I want to particularly talk about is this thing called the JWTS URI. And what this brings you to is a JSON document that describes the key material that you can use to validate tokens that are being issued by this authorization server. And you know, what you're seeing here on the screen is a public key. It's an RSA key. This authorization server has the private key to it. Then the authorization server would sign the token with the private key. You can use the public key to validate the token, right? No need to hard code these things on the server. You can discover them dynamically at runtime. But even better, as you can see, this is all designed around the notion that you can rotate those keys. There, you know, like many installations I see is they create a key pair at installation time and then run with it for many, many years. Yeah, as you can see, that specifically it's a keys entry, and it's an array. Yeah, so the whole format is designed to have more than one key and being able to rotate your keys periodically. Also, the other thing I want to highlight here is that you have crypto agility by specifying which signing algorithm you are using, and you can again have more keys with different signing algorithms. Yeah. So, long story short, the spec explicitly is prepared for you to rotate your keys, and that can be completely automated. Yeah, and it's a good crypto hygiene to periodically get a new key, throw away the old one. And while there are no golden rules how often you should do that, I think since, you know, Let's Encrypt exists, they show that it's totally possible to rotate keys, even X509 certificates, which people, you know, never try to touch anymore after they got them, to rotate them, for example, every 3 months. Yeah. So that's one thing. Yeah. You should rotate your keys. You should keep, or typically you want to keep a history of at least the previous key, so that, you know, at the time of rotating, that your old access tokens still validate, the ones that are still valid. And then once, you know, depending on how old your access tokens can get, you can get rid of the old keys at some point. The next thing I want to point you to is that RSA, even if it's used everywhere today, is not the only signing algorithm that you can use. Yeah. OpenID Connect or OAuth, well, at least OpenID Connect, mandates that you have to support RSA or RS-256, which stands for RSA with SHA-256. But newer specs like the Open Banking or PSD2 spec, they require PS-256, which is an updated version of that, which basically, you know, the idea that with RSA, if you sign the same piece of data multiple times, the signature will always be the same. But with PS, the signature will look different every single time, which gives, you know, a crypto analyst less data to work with. So that's why this is a better, more secure algorithm. You know, standards in the healthcare sector require things like elliptic curve-based algorithms, for example. So, you know, long story short, you can do all these things, but you have to do it, basically. Let me quickly show you how that looks like in IdentityServer, right? So if you have an OAuth authorization server that supports these features, well, in our case, all you need to do basically is you have to tell us, this is how often we want to rotate our keys. This is how long before we switch to the new key we want to announce that new key so that clients can learn about it. And this is how long we want to keep old keys so that old access tokens will still validate after we made the switch to the new key. Okay. The other thing I want to show you is that you can basically just say, okay, and by the way, we want to offer these algorithms so that clients, you can on a per client or on a per API basis configure which signing algorithm you want to use, right? And the thing is that you often cannot migrate your system in one go. So maybe some of your applications stay on this because they have to, but newer APIs or newer clients might want to upgrade to these newer algorithms. Okay, so if I run this, let's go here. You see that here's a keys folder. So by default, in development mode, we just store the keys on the file system. But basically, the very first time you run the server, you don't have any keys. And then when we hit the discovery endpoint, there's a short delay that is used for synchronizing in a web farm. But then suddenly something will happen. And if we have a look here, you will see now that there are 3 keys being created. And if we look at here, you see that we indeed have 3 keys now, yeah? And each of them have a different signing algorithm, and each of them are now rotated periodically, basically. So that's fully automated, and that's how it should be. You never, ever again want to shut down your server just to update your key material, right? So yeah, so that's that. Good. What's next? So the next thing I want to talk about is basically the job profile for OAuth access tokens. As I said, it's quite funny that the industry has been using JSON Web Tokens for many, many years now, but no one, there was never a standard. It just happened, right? Because it was just an easy to use format. So if you look at the OAuth spec, right, the OAuth spec says nothing about access tokens, yeah? The only example they give you is that that's how an access token looks like, right? And probably the guy that wrote the spec just hit his head on the keyboard here, and that's the access token, yeah? But JWTs are so convenient to use, right? Because they are self-contained, they have good library support. So that's what just happened, right? Now the problem with that is that there was no standard, yeah? So whereas in OpenID Connect, the standard was very explicit how an identity token must look like. In OAuth, access tokens are complete, freestyle. Yeah. It doesn't help that the JWT spec itself makes all the claims optional. Yeah. So yeah, that's another thing. So what we learned is basically we need, or it would be good to have a standard way how to convey user and client identity. It would be good to have a standard way how to communicate lifetimes or valid time windows, yeah, so to speak. It would be a good way to have a standard format for conveying the scopes the user granted to the client in the access token. And we actually funnily enough, found some interesting problems that just arose because JWTs became so successful, and they are called Cross-JWT Confusion vulnerabilities or substitution attacks, and I'll show that in a second as well. So just to briefly walk through what the new JWT profile for OAuth suggests is, first of all, the usage of the client ID claim, which always will identify the OAuth client ID, and the usage of the SUB, the subject identifier claim, as well. Now, this here is a bit polarizing, I guess, but what they describe in the spec is, if a user is present, the subject identifier is the user ID as defined in OpenID Connect. If it's a pure machine-to-machine communication flow, the subject ID is the client ID, okay? And what I don't like about it, but that's the way it is that, if you have both the client ID and the subject ID and they are the same, there is no human being involved. If they are different, then one is the client ID and one is the user ID, okay? The other required claims that are now in that RFC is the issuer claim, expiration, audience, issued at, and JTI for providing a unique identifier for things like replay attacks. Yeah, so that's basically how one of these tokens could look like. You have an issuer, an audience, an expiration, and an issued at, a random ID, subject ID, client ID, and basically this is the list of scopes that got granted at token issuance times so that the resource that receives the token can do authorization decisions. So that's how that would look like. And, you know, to be honest, many authorization servers came, you know, were developed in the past. They might have used slightly different formats. We used slightly different formats as well, but we now have config settings to basically toggle between the old and the new style. So it will take quite some time until they harmonize, and if they ever will, so to speak, yeah. But at least this document gives you now a common language, so to speak, in at least knowing how a JWT, you know, should look like. Okay. So the other interesting thing is that, you know, JWTs are so ubiquitous now, yeah. You know, since they're so easy to create and so easy to transmit and so on, that people started using JWTs for all kinds of purposes, yeah. For example, for access tokens, for identity tokens, for logout tokens, and for all kinds of custom token types. And we realized, they look so similar, so that if you are not careful enough, you might confuse one type of JWT with another type of JWT, okay? And that's what is called cross-JWT confusion. So for example, if you look at the validation procedures for a logout token, right? I mean, they for most parts look very normal, right? Validate this, validate that, and so on. But then they say like, verify that it does not contain a nonce claim. Why? Well, because if there is a nonce claim in it, it would be indistinguishable from an identity token, yeah? And now there's confusion, right? So long story short, I think one of the best things ever is that they introduced strongly typed JWTs. And that means that the type claim or the type field in the header now has a value saying like, hey, I am an access token. So that stands for AT, access token plus JWT, and it's roughly, you know, like it's inspired by media types in HTTP. Okay, so now what you should do in the future is when you are an API and you receive a JSON Web Token, you should make sure that if your token service supports this, that the type header has the word AT plus JWT in it to make sure it is actually an access token. Cool. Next thing, resource isolation. That's a big topic, yeah. Especially when you have bigger API services and bigger systems, yeah. So you know that OAuth, OAuth is 9 years old now, yeah, and it couldn't foresee that it was actually being used in these diverse environments, yeah. So they looked for an easy way for a client to express what it wants to access, yeah. So they introduced this scope parameter, and basically, and I copied the original text from the spec here, and as always, the spec is very relaxed about this. Yeah, it says it's something that specifies the scope of access. Yeah, it's a space delimited list. The more values are on there, the more things you are requesting. Yeah, and also the server may fully or partially ignore the scope, right? Because, well, why not? Now, there are many ways to model these scopes, right? Because the spec itself doesn't give you anything, yeah, right? It just says, here's the scope parameter, put some random stuff on it, yeah? So you basically have to come up with, okay, so here are the things that a client can access in my organization, and now let's give them names, right? And then once they have names, we can start doing some access control, maybe which client can access what, or we can use them to populate consent screens, things like this, right? So, just as an example, that's how GitHub structures or an excerpt of their scope surface, right? So they have things like repo. The repo scope gives you access to repos, right? The user scope gives you access to user data. The packages scope gives you access to the package feed. But also they had to subdivide their scopes, right? Because things like write packages, read packages, delete packages, because you want finer granularity, right? And they came up with this colon delimiter, and as you can see, older versions, it seems, used underscores, for example, yeah. But yeah, so everyone that ever designed an OAuth-based system is that you end up with many, many scopes, right? And then you pass along these long strings, and the more things a client has access to, the longer the scope parameter gets, right? And if the client has access to many things, these tokens become super powerful, right? Because now they can access many things. And if they leak, well, whoever gets the token has access to many things, right? And if you look at an even bigger API surface, for example, with Google, right? They have, you can imagine, completely different APIs that are built by completely different teams, and which are totally independent of each other. And they used a similar concept, right? They had they introduced namespaces of their scope names, yeah? This time they used URLs, right? So you can imagine the BigQuery API is written by someone completely different than the Gmail API. So, again, you look up their documentation, you figure out, okay, what is this string I have to put on the scope parameter? And that's what the client gets access to if the client is authorized, of course. Yeah. As I said, this is a simple system, and if your application space is small enough, easy to handle, but as I said, you probably know that the bigger your surface gets, the more stuff you put on this scope parameter. Yeah. Now, as I said, the problems with this model is that tokens can become very powerful. Yeah. The other thing is, let's say a client has access to completely different, unrelated APIs. So nothing is stopping that client to ask for all of the scopes, right? And they end up all in the same token, even if this token, or even if the scopes are unrelated. What if you want to put API-specific data in the access token, for example? Now the other API will see the data of this API, and what if they become ambiguous, right? And so on, yeah. And another thing is, what if you have multiple APIs that use the same scopes? Yeah. So we have a customer. In the healthcare sector, there's a standard product called Smart on Fire. They define standard scopes, but what if you now have multiple systems? Yeah, when you now ask for the patient scope, for which system will that scope be, for example? Yeah, and if you grant access to both systems, there is a certain concern that system A could now take the access token and talk to system B directly, even if they should be in different trust zones, right? So that's basically here what I'm showing you here on that slide, right? What if there is a trust boundary between the APIs? What if the orders API should not see the data of the invoicing API? Should the orders API ever be able to call the invoicing API? And so on, right? So long story short, this becomes a bit messy. The more scopes you have, the more complicated it becomes and the more powerful your tokens get. And there is no way to, well, unless the client is very disciplined, of course, yeah, to separate them out, okay? And that is exactly where resource indicators come in. That's an RFC 8707. It introduces a new request parameter called resource. And what the resource indicates is that you can, in addition to just specifying the logical scope names, you can also specify physical or logical resource names in which context this scope would be used, okay? So how is this useful? Well, basically what it allows to do is to still do a single front channel request to an authorization server, but say like, let's give me access to two resources, and the ultimate result will be two separate access tokens, one for resource 1 and one for resource 2, which solves many problems, right? One is that the tokens get less powerful. You can have resource-specific processing, like, for example, encryption or claims in that token. And obviously, since the resources are separated out, there is no, resource calling another resource problem, because the token for resource 1 would not be good at resource 2. Okay, so that's basically what this spec tries to achieve. This is not for everyone, right? But if you feel the pain of a large API service and you would keep things more separate, yeah, then this is exactly for you. So how does it work? Well, basically, the resource parameter is an additional parameter on the authorize request. Yeah, so in this case, you see that basically we're doing a standard authorized request, but we are saying, we are indicating that we want an access token for invoice.api.com and another access token for customer.api.com. So we want two separate access tokens, so they are separate from each other. Yeah. Now, how does that work? Well, what you will get back is an authorization code, just as normal, right? And then when you redeem the authorization code, you say, okay, and now give me back a token for invoice.api.com, and the access token that will come back from that token request will have the audience set to the resource name, which means this token can only be used at invoice.api.com. So now the question is, how do I now get the other access token, right? And the way this works is basically what you also get back is a refresh token. So if you now want access to the order API, I think it was called, you use the refresh token, hand in the refresh token, oh, sorry, customer API, hand in the refresh token, indicate now that now you want an access token for the customer API, and then this will return an access token that is which audience is now the customer API. Okay, so ultimately what you end up with is well, 3 tokens, if you like, yeah. One refresh token that will allow you to get all the others, and 1 token for the API, for the customer one, and 1 for the orders. Yeah, and then the client manages these independently and then uses the corresponding access token to call the right API. And that, as I said, allows you to put customer API specific stuff in here, to do customer API specific processing. And as I said, the customer API will not be allowed or cannot call the orders API. And if you are leaking this token, you're only leaking it for one API and not for all the APIs which are included. Okay, so again, let me show you a demo of that. So the way this works in IdentityServer is basically when you go to your configuration and you're doing your resource definitions. Yeah, let's scroll up a little bit. Here are my resource definitions. Yeah, you basically give those resources names, and these are the names you would use for the resource parameter. And for these two, you basically say, you can use the resource parameter if you want to be a well-behaved client. But here, that's the new thing, is we can also say require resource indicator. And now you can only get an access token for this resource if you specifically use the resource parameter, which in other words means that what this resource is expressing here is, I want my own access token. I don't want to share my access token with anyone else. Okay, that's basically what this is. What this is saying. So I have a little test client here that I'm using to to walk through these scenarios. So let me quickly show you that. I can do many things here, but let's just stay with the example we had on the slides. So basically, I want to ask for 4 scopes, yeah, for scope 1 and 2 of resource 3, and for scope 1 and 2 of resource 4. Okay, so if I would not use the resource indicators, I would get a single token which had all the scopes for both resources. But in addition, I'm using the resource parameter select. And by the way, I want 2 access tokens, one for resource 3 and one for resource 4. Okay, so let's do that. So that will open my front channel. I need to authenticate. Okay. And that will, well, go away. Just give me back an access token. So now you can still redeem the code without specifying the resource. Otherwise, we would break every single client library out there, right? If we would not accept this anymore. But as you can see, the access token you get back without specifying the resource does not have an audience claim. Okay, so if you now would take this access token, send it to an API that does the audience check for resource 3 or resource 4, it would fail, because this is basically an access token without audience. But still, you need to do it like this because there are scopes here, for example, which are not resource bound, like the OpenID scope, for example, right, which is coming from OpenID Connect. Cool. So now we have the refresh token, and now we can say like, okay, now give me a token for resource free. Right? So I'm going to press C now. Okay, and you see what you're getting back is now an access token which has an audience value of resource free and only includes the 2 scopes for resource free. Okay, so now this would be a resource free specific token. And now I can do the same thing with resource 4. So I press D, right? This time I'm getting a token that has the audience of resource 4 and only the scopes that belong to resource 4. So what we achieved in essence is we now have 2 access tokens for the 2 resources that we asked for in the first place, and they are properly separated. Okay, cool. So that's that. Cool. So the next thing I want to talk about is 2 new standards. One is in the last stages of being published, and the second one is very soon to be published, and they care about strengthening your front channel, right? What happens in the browser. So as we all know, the browser is the weakest link in the chain. So, normally what we do is we send this list of parameters to our authorize endpoint, and there is a certain potential for confusion if an attacker can on the fly either read them or manipulate them, for example, yeah. And many security researchers have criticized that there are so many parameters here that an implementation that validates all of that must be very, very battle tested, right? Because you can play around with all of these things, yeah? So what the job secured authorization request basically proposes is, instead of transmitting all of these parameters in clear text as key value pairs on the query string, we just take them and turn them into a JSON Web Token. And this JSON Web Token replaces all of the parameters besides the client ID. Okay, so basically we took all the parameters here, turned them into a JSON Web Token, removed the parameters, and replaced them with a single one called request. And this is the JSON Web Token. And if we would look at the contents of the JSON Web Token, it looks like this, basically. It's a JSON Web Token, with a header and a payload, and all the parameters you've just seen, like response type and redirect URI and scope and so on, they're all now inside the JSON Web Token. This has a couple of advantages, right? A, those parameters cannot be manipulated anymore in transit because they are signed. Yeah. So basically, the authorization server can trust the contents of this token because, if the signature is valid, we know no one has tampered with this data. Once the signature has been validated, we can authenticate the client on the front channel already, right? We don't have to wait until the back channel communication. Already on the front channel, we can authenticate the client and reject unknown signatures, right? It's a nice touch here. This is, a not too hard to implement way to basically make your front channel much more secure. Okay. Again, let me quickly show you how that looks like. In IdentityServer, where's my jar client? Here's my jar client. And basically what you see is, instead of using a symmetric key here as a secret, in this case, we configured an RSA key. And that basically means the client will use the private key of that key to generate the request parameter. And on the front channel, when the request comes in, we will validate it using the public key, which is stored on the authorization server. And again, similar to the require resource indicators, we can say require request object, meaning for this particular client, we only accept requests if the authorized request is signed. Okay, again, pretty simple to set up. And just to show you an example how that would look like in MVC, which would be probably a typical client, right? So here's my MVC client. And Microsoft has all the extensibility points that you need to add this feature, even if, by the time they wrote it, they didn't, plan for it explicitly. And you can do that by handling the events of the OpenID Connect handler. And there's a class called the OIDC events class. And here you see there's a method called redirect to identity provider. This happens directly before we redirect to our provider. And then basically you see that on that context, we get the protocol message that is going to be sent to the authorization server. And we're going to sign that protocol message. And then we're going to clear the protocol message and add the request parameter here. Yeah, there's one little thing in ASP.NET Core that you cannot change right now, is they require this to be present, the redirect URI, but that's not a big deal because it will be ignored by the authorization server once the request object has been found. So in other words, if you're sending a request object, only the data inside the request object will be considered for the request. Okay, so let's run this. Char, here it is. And just open the network tab here and now authenticate. Okay, so as you can see here, here's my authorize request as it was sent to the authorization server. And here you can see, here's the request parameter, basically. Yeah, so that is replacing all the other normal OAuth or OpenID Connect parameters with this signed object. Okay, cool. So that's that. That's called char, yeah, as people call it, for JSON JWT secured authorized requests. Now, the downside of this approach is that your URLs get very long, yeah, and that might be an issue for mobile scenarios, for example. The other thing is apparently that the client software, that the client library needs to be able to create JSON Web Tokens, deal with the crypto things and so on. So that's the, that's the downside, but the security benefit is pretty good. Yeah. To make this a little bit easier, there's another spec which sits on top of char, basically. It's called PAR, for pushed authorized requests. Yeah? And the idea is, instead of the client having to create that JSON Web Token and putting it on the query string, how about the client would first, before he even opens the front channel, open a back channel to the authorization server and basically push all of the parameters, to the server. Okay. Again, this call can be authenticated, yeah, which gives us the same benefits as with char. We can authenticate the client even before the first request happens. But the client does not need to do the crypto. It does not need to put all these parameters on the authorized request. It first uploads those parameters, and then the authorization server will return as a response to this call just an identifier for the uploaded parameters. And then all the client needs to do is, when he actually now starts the front channel, it will include that identifier on the authorized request, and then the authorization server will internally substitute basically the previously pushed parameters on this authorization request. Yeah. So same idea, authenticate the client, remove the parameters from the front channel so they can't be tampered with. And that, I think, will be the most popular way of doing that, because it's super easy, no crypto required, no key material required, and so on. So this spec will soon be ready, and I can't wait to implement it, to be honest. Okay, cool. So next thing, we have 10 more minutes. Proof of possession access tokens. Yeah, as I said, that's a hot topic in the OAuth world, because basically, back when OAuth was specified, or OAuth 2.0, I should mention, to go even one more step back, OAuth 1.0 had proof of possession tokens, meaning the tokens are bound to the client and only the client can use them by bringing in some key material into the mix. Yeah? With OAuth 2.0, they dropped that feature to make it simpler to use, right? And not everyone was happy about that. And that was the reason why the OAuth spec was split up in two specs. One was OAuth itself, and one they called the bearer token usage. And the promise was, well, that they will add the proof of possession token usage afterwards, and just wanted to get the bearer token thing out of the door to focus on this. But guess what? This never happened really. Yeah. So we were for almost 10 years, I guess, in a situation where OAuth itself did not have a concept besides bearer tokens. And the issue with bearer tokens, as I said, is if they leak, whoever has them can use them and impersonate the client and the server, right? There's nothing stopping them. It's like cash you're losing on the street, right? Whoever finds it can use it, right? Now, there have been many attempts to solve this problem. Yeah. Some people wanted to solve it at the application layer. Some people waited for changes in TLS called token binding. Long story short, they never happened. And so we were, almost 10 years later, there was still no solution for that. Yeah. But there are industries who absolutely need that feature, yeah, like banking, healthcare, and so on. You just cannot afford that a leaked token can be used in a banking system or in a healthcare system to, cause problems. Yeah. So 1.5 years ago, or maybe 2 years ago, someone jumped in and said, okay, even if this is not the most sexiest solution on the planet, we can do something about this, and we will basically go back to good old mutual TLS. Okay. So, when many people hear mutual TLS, they say like, that sounds complicated. And so, things like PKI and CAs come to mind and so on. But to be honest, these days, it's not so bad because mutual TLS can be used in many ways. It does not require a PKI. It does not require certification authorities and so on. So there is now a spec that says, like, if you want to use mutual TLS, we can give you this proof of possession feature. Yeah. There's another spec which is still in the works called DPop, which achieves a similar goal, but without the whole mutual TLS thing around it. Yeah. So I show you mutual TLS first because that is available today, and then I'll quickly show you DPop. That's coming maybe this year, maybe shortly after, I guess. Okay, so ultimately how proof possession works is that you present some sort of proof to the authorization server, some key material typically that, like a public-private key pair, things like that, where you only the client knows the private key or the secret, so to speak, yeah. And then what the authorization server will do is it will embed that key material into the access token itself, okay? And that's called the CNF claim, the confirmation claim. And then when you send this access token to the API, you prove to know that secret in addition, and then the API will look at the CNF claim, will look at the thing that you use to prove your secret, and if they can validate it, you have proven that you are the same client that asked for the token in the first place, and not someone who just stole it and tries to replay it. Okay, that's the idea in short words. That could be in a JSON Web Token. That could be via introspection. Yeah. So basically, what mutual TLS does is it proves to both parties that the other party knows a private key. Right. We know that with server TLS, right, HTTPS, basically, the server proves to us that it's Amazon or whatever before we send them the credit card. And client TLS is just the opposite direction, where the client proves to the server that it knows some secret, and that secret can be used then to bind the token to the client. Yeah. So the way this works is basically it's actually really simple, and I think it's a nice thing to do. Is that in your client code, yeah, and I think that is especially attractive for things like mobile apps, for example, right? Where you have the crypto, but you are on typically untrusted networks, yeah, like the internet or, you know, the hotel, Starbucks, whatever. So what the client can do is it can create an X509 certificate on the fly. Okay, so there's no need to pre-register this at the token service, just create it on the fly and then use that created certificate to make the token request. Okay, so basically you bind that to your socket and then you're making a token request. Okay, so now what the token server will do is it will issue the token back to the client just as normal, but in addition, it will add the CNF claim, which contains the thumbprint of the used X509 certificate. Okay, so now when the client now calls the APIs, it will use the same client certificate and the access token, and then the API can look at the TLS channel, gets the certificate, looks at the thumbprint, compares that with the thumbprint in the access token, and if they match, well, the client has proved that he is the owner of the token, which means proof of possession. Yeah, sounds complicated, and it is complicated, but it's actually not that hard to implement. Yeah, so let me show you that. So basically, let's run the API as well, and let's run our mutual TLS client. So basically now I'm doing exactly what I showed you on the slides. I created this certificate on the fly. I made a token request. And by virtue of that client certificate being present on the TLS channel to the token service, IdentityServer basically creates that CNF claim and embeds that thumbprint inside the access token. Okay. So now when we look at the API, so when we look at the pipeline of the API, right? So that's our normal ASP.NET Core pipeline. But we have now two authentication handlers. One is for our JSON Web Token, and one is for our client certificate. Okay, and as you can see, we basically allow all certificates. So in other words, they don't need to be bound to a PKI. They can be created on the fly. So, and then in our pipeline, basically after we do the normal token validation, we also validate the confirmation claim, meaning we compare the value in the access token with the value on the TLS channel. So in other words, if I now press enter, I'm making an API call, and that should work because these claims match up, and it did. Okay, so no exception means it's good. Okay, so yeah, as I said, this is a huge topic that we could talk for much longer, but the purpose of this talk is just to make you aware that this exists, make you aware that in .NET it's pretty easy to implement actually, and yeah, something to consider. So the very last thing I guess I want to talk about is this DPop thing. This is not yet a finalized spec, but it is in the works, and the idea is that this is basically an application level proof of possession mechanism where you don't need the MTLS infrastructure for, okay? And the way this works, just to quickly show you the general idea, is that same concept, yeah? When you are asking for a token, you're sending along something else that proves the knowledge of a secret, and that's what they call the DPop token or the DPop header. Yeah, and what this header is, it's another JSON Web Token where you basically create a public-private key pair. You embed the public key into this DPop token. That's this guy here. Then you put in some claims, like for example the URL and the HTTP method and timestamp and so on. And then you're using that private key that you just created to sign that token. So now when the authorization server receives that token request, it will validate the signature, and that means you have proven to know the private key that belongs to that public key here. And then what the authorization server will do is basically embed an identifier for that key material into the access token. Yeah, same idea, the CNF claim, but this time they're using not the thumbprint of the client certificate, they're using the base64 URL encoding of the JWT SHA-256 thumbprint of the public key. And there's an RFC for that, of course. Long story short, this is basically a key identifier. Okay, so now same idea. If now the client makes the call to the API, it will call the API, it will send the access token, which includes the CNF claim. It will send an additional token, the DPop token. And what the DPop token is, again, is using the same key material that we use to, add the token service. We're embedding the URL and the HTTP method. And again, by being able to validate the signature, the API knows that we actually know the private key, which again proves that we own the access token. Okay, so yeah, don't feel bad if this is not crystal clear after just being exposed to it for 10 minutes. It's fine, it is complicated, but my point is that with the ability to be able to bind access tokens to clients, we eliminate a whole class of problems with basically leaked access tokens. Yeah, and they might be leaked by application code, they might be leaked by by attacks against your system. The point is, if the token leaks, you don't care anymore, right? Because it's bound to the client, and this token can not just be used now to impersonate or call APIs. Okay, cool. So that's it. That's all I have. I guess the summary is that, as you can see, OAuth keeps evolving. It's not just RFC 6749. There's a lot going on, and that mainly that the reason for a lot going on is because it's so popular, right? Maybe 10 years ago, they didn't think it's becoming that popular, but it did, and it's used everywhere now, right? E-governments, healthcare, banking, you name it, yeah? That's why basically there is a good interest in strengthening it and making it ready for the next 10 years, I guess, yeah? So that's why OAuth 2.1 will be released soon, and that's why these additional specs exist that, add additional security features. So, I'm working as a consultant, I'm helping people, I'm doing training, so if you have any additional questions, whatever, let me know. And yeah, now I'm going to be in Slack, and you have my email address. So yeah, thank you for your time, and hopefully see you again next year in person. I'm pretty sure you heard this sentence before. Thank you.